Alright, so finding the x and y intercepts of any equation. So we're just going to come over here real quick. Let's go. And look at a basic linear equation. Bam, bam. So where is my x-intercept? Where is it? I don't have any numbers on here, so I'm not looking for a value, just a location. Where is the x-intercept? What does the word intercept mean? Crosses, right? So the x-intercept crosses what? The x-axis. My x-intercept is where the line or graph crosses the x-axis. That's your x-intercept. It literally means where it intercepts the x, right? So the x-intercept is where your line crosses the x-axis. So right here is where my line crosses the x-axis. Now I don't have any values again on my graph, but what do I know about this coordinate? The x value is negative, sure. But if I flipped my graph and put it over here, it'd be positive, right? So I could change that. What's not going to change? Even if my x-intercept was over here, what is the y value? It's 0 every single time, right? This coordinate is some value of x, comma 0. And it doesn't matter where the x-intercept is, that will always be true. So on my x-intercept, the y value is always equal to 0. Alright, so what about the y-intercept? Where is the y-intercept, or what is the y-intercept? Very good. It's where the line crosses the y-axis, or intercepts the y-axis. And I say line very loosely, right? My graph doesn't necessarily have to be a line. Curve. Curve's probably a better word. But you can keep line, it's all good. So where my graph crosses the y-axis, and again, look at this point. So I have, this is my y-intercept right here. And I could slide it up, down, all around. But what is going to hold true at this point? The x value. The x value should be 0. And it doesn't matter where it crosses on the y-axis, the x value will still always be 0. And so we're going to use these two facts, the y is 0 at the x-intercept and the x is 0 at the y-intercept, to find the x-intercepts given an equation. Given a graph, it's pretty straightforward, but given an equation, it takes a little bit of work sometimes. So let's go to an example. I want to find the x and y intercept. We'll start with a fairly basic one. Given y equals 3x minus 2. So I want to find the x and y intercept. So let's say I start with the y-intercept. So I'm going to use the fact that x is equal to 0 at my y-intercept. So I'm going to plug in what I know. I know that x is 0. So I have y equals 3 times 0 minus 2. 3 times 0 is 0. So I have y equals 0 minus 2. So y equals negative 2. So I know my line or my curve, depending on what the graph looks like, crosses the y-axis at negative 2. Right? That ordered pair, if we were asked for it, would be 0, negative 2. And so the x-intercept works about the same, except at the x-intercept, I know that y is equal to 0. So I'm going to plug in y equals 0 and solve. So I'll have 0 equals 3x minus 2. Now this is an equation. I got to solve for x. So I add 2 to both sides, so I get 2 equals 3x. and divide by 3. So I get x equals 2/3. So I know this line crosses the x-axis when x is equal to 2/3. And that ordered pair is 2/3, comma, 0. Now this fact, the way we go about doing this, means depending on the type of function or type of equation I'm given, I'm going to have to use the equation solving skills that we have accumulated thus far. So let's look at another example. Same task, I want to find x and y intercepts given, let's say this time y equals x squared plus 5x plus 6. What type of equation is this? What type of function is this? It's a quadratic, right? So I'm going to start off, again, finding my y-intercept. And we can use the property that I know x is equal to 0 at the y-intercept. So I'm going to plug in 0 for x. So I get y equals 0 squared plus 5 times 0 plus 6. 0 squared is 0, plus 5 times 0 is 0, plus 6 is just 6. So my y-intercept for this function is y equals 6, and that coordinate would be 0, 6. And now likewise for the x-intercept, we'll use the property that y is equal to 0. I'm going to plug in 0 for y. And I'll get 0 equals x squared plus 5x plus 6. Now we've looked at how to solve things like this before. How could I possibly solve this? I could try factoring, right? I could try factoring. What other options do we have? I could do the quadratic formula, and what else? It'd be ugly, but what could I do? Thank you, Jazz. Completing the square, right? So we actually have 3 different options. I don't care which one you use, whichever one is best suited to your liking, that's totally fine. But you need to use one of them, all right? I look at this and I know that it's factorable, so I'm going to factor it. What does this quadratic factor into? Sorry, video watchers, that was gross. But what does this factor into? So remember, I don't have a number in front of x squared, so all I'm looking at is my last number, so the 6. And I want to know what numbers do I multiply together gives me 6. When I add it together, I get 5. 3 and 2, 2 and 3. So I have x plus 3 times x plus 2. Now that I have it in factored form, I can use that 0 root property that we talked about before and set them individually equal to 0. So x plus 3 equals 0, x plus 2 equals 0, and I get x equals -3, and x equals -2. So this one actually gave me 2 x-intercepts, and they would be -3, 0, and -2, 0. Right? So depending on the type of function, we could have multiple x-intercepts. And I could also have a relation, something that's not a function, turn the other way and get multiple y-intercepts, right? But the process will work the same every single time. Get your y-intercept, plug in 0 for x. Get your x-intercept, plug in 0 for y. All right?